We will now begin AIDA Engineering's presentation. This 2-point servo press is the AIDA DSF-N2-4000A direct servo former that we launched last year. This is the first press equipped with AI functionality, and the tough and smart DSF-N2-4000A press features 3 evolutions compared to conventional presses. The first evolution is Basic Performance Evolution. In recent years, the number of forming stages in a press has been increasing due to a growing number of formed products with complex shapes. This press delivers the widest area and longest stroke specifications available for a unibody general-purpose press. In addition, we have optimized the position of the frame members that support the bolster to reduce bolster deflection and boost bolster rigidity. We have improved the dynamic accuracy to enable high-precision forming. And we have achieved even better dynamic accuracy by distributing the load applied within the slide area in order to bear the load in a balanced manner. Productivity has also evolved. This press utilizes servo motors in a twin-drive configuration. And it also boosts productivity by further increasing the torque and RPMs. Compared to past presses, this translates into an 67% boost in productivity for crank motion, and a 39% boost in productivity for pendulum motion applications. The second evolution is the Factory Automation Compatibility Evolution. This press is equipped with an AIDA-made transfer. For the DSF-N2-4000A, the peripheral and auxiliary equipment screens have been incorporated into the press HMI screen, meaning all operations can be performed from a single location. You can access the load monitor screen by pushing a button on the press HMI screen. The transfer HMI screens are also accessed in the same way. This press is equipped with a newly developed touch input interface that allows the intuitive, visually confirmable inputting of settings for various operations. When this new press product is equipped with a transfer, it is now possible to select between crank motion and pendulum motion as standard. Moreover, this press can be synchronized to run together with the transfer even for flex motion applications. Using the same die that was used for pendulum motion, the recipe is switched to perform composite forming using flex motion. This shows the previously inputted flex motion settings in action. This is the side piercing die. And this is the index table. After the product is conveyed to the final forming stage, a side piercing die is actuated by a cylinder and side piercing is performed by means of a cam unit. Following this, the index table is rotated to enable multiple side piercings using the same die. Using a system like this has enabled stable production using compact dies and without adding forming stages. The third evolution, the Intelligence Evolution, is the greatest new feature of the DSF-N2-4000A press, and it delivers new functions that fully leverage digital technologies. The DSF-N2-4000A was the first press in our industry to be equipped with AI machine learning as a way to enhance preventive maintenance functions. Up to now, press maintenance has been performed based on the cumulative knowledge and skill levels of the involved workers. In addition, the experience levels and judgment criteria of maintenance personnel differ, making it difficult to perform targeted maintenance. And in a worst-case scenario, the equipment could be in a serious near-breakdown condition by the time a fault is detected. The AI functions of this press take the place of workers in monitoring dozens of data points. And its self-diagnosis function outputs two-tiered warning level and fault level alerts when anomalies are detected. This can help you achieve stable production by helping to prevent press issues and serious breakdowns. We'd like to now introduce another helpful function to achieve stable production. If you press the Real-Time Monitor button, you can verify the forming conditions from the operation panel to an even greater extent. Production has been suddenly interrupted. It looks like a misgrip has occurred. In cases such as this, it is possible to use the recorder function to check the cause of the stoppage. This function enables you to see a video of the inside of the die at the time the fault occurred and to also confirm the press status on the same time axis. Likewise, the 3D CAD data of the press is included in the operation panel to enable you to visually confirm press faults. For example, if the temperature of the main motor were to become abnormally hot, you can see at a glance which part of the motor is faulty by clicking on the location where the abnormality occurred. There is also a screen that can be used to check carbon neutrality related information. This is the electric power monitor. This screen can be used to calculate the amount of CO2 emissions per product. And this press is also equipped with an energy saving system. This function has two primary features. First, peak current is suppressed by using capacitors, which enables a 33% reduction in the capacity of the factory power source compared to a press without capacitors. Second, when the press decelerates near top dead center, the electric power regenerated by the servo motor is returned to the capacitors, thereby enabling high power efficiency. That's quite the advantage. We hope you have enjoyed this introduction to our high-rigidity, high-precision DSF-N2-4000A servo press. It is a press that can accommodate the shift towards ever larger dies, such as the dies used to form large-capacity battery cases for electric vehicles, the demand for which is expected to increase in the future. This completes our presentation. Thank you for watching. If you have any questions, please do not hesitate to ask any AIDA associate.